What's up, guys? We're going to be looking at section 3.3 from our textbook today, systems of inequalities. Now, we've talked a lot about systems of equations so far this chapter. System of inequalities, not too much different, especially if you remember 2.7, which was how to graph inequalities. So, like that section, our solution is actually just going to be in the form of a graph. We're going to be drawing lines, we're going to be shading regions, and we'll see it right now. So if we are given this system of inequalities, y is greater than 2x plus 4, and y is less than or equal to negative x minus 2, step one is we need to graph these guys. So I'll graph the first one in red. And so 2x plus 4, I'm just going to graph that as if it were a line. So positive 4 is my y-intercept, slope of 2, so up 2 over 1 or down 2 left 1. Grab my ruler. Now, if you remember from section 2.7, we do have to ask ourselves, should this be a solid or a dashed line? Because it is just greater than and not greater than or equal to, I'm going to make this a dashed line. So really clearly a dashed line. And then it says that I want to shade, because this is an inequality, everywhere where y is greater than this line. So here's how I always do this. I find my y-intercept, and I shade right above it because I want greater than. So something along these lines, doesn't have to be perfect. That region is the solution to my first equation. Y is greater than 2x plus 4. Let's do my second one. So my second one, I'll graph in blue. Y is less than or equal to negative x minus 2. So I'm going to go down 2. My graph got a little misaligned, but that's okay. So we'll say this is negative 1, this is negative 2, negative x, so down 1 over 1. Grab my ruler and solid line or dashed line. Well, this was a less than or equal to, so I'm going to draw a solid line right up against my ruler. And I want less than or equal to, so I need to shade below this line. So let me grab my blue highlighter and shade everything below this line. So I shaded above my red line, I shaded below my blue line. What is the solution to this system of inequalities? It's wherever in the graph got shaded by both colors. Now, this is not, because it didn't get shaded by anything, this region. This was only shaded by red. This was only shaded by blue. I need to get rid of those. I'll leave that green one there. Nope, it got rid of it. So reshading below. But where is our solution? Our solution is where we got shaded by both. So in this case, beneath the blue line, above the red line, and it turned kind of this dark, very dark gray, maybe black on my screen. I will just grab yellow and say, this right here is the solution to this system of inequalities. This whole region that's above red, but below blue. So we're just graphing basically two inequalities on the same graph and making it really clear where were we shading both. Let's try another one. I'll use the same, I might switch up that second color. That was kind of hard to see. But y is greater than or equal to negative 3/4 x plus 1. So plus 1, slope of down 3 over 4. Grab my ruler. I know that greater than or equal to, so this can be a solid line. Put that up there, and y is greater than or equal to that. So I will grab my red and shade above that line. Y is greater than or equal to, that's my first one. Y is less than or equal to, I'll do this one in green. So negative 2, slope of negative 3/4, so also down 3 over 4. Grab my ruler. It's less than or equal to, so I can Go ahead and get that solid line going. And less than or equal to means shade below. So where on this graph did we shade both red and green? Well, the answer is nowhere. And we've seen this as a possibility sometimes, right? No solution. This system of inequalities has no solution. Nowhere on the graph does it work for both red and green. So this one, just no solution. We leave the graph as is. There's nothing to like really darkly shade and make sure that it's clear that it was shaded by both. So the other thing we can do from this section is we can find vertices of where these lines for the inequalities meet. So if you're looking at the screen, it says find the vertices algebraically and graphically of the figure formed by the system of inequalities. I'm going to show this both ways, first algebraically and then graphically. So algebraically, if we're trying to find where these lines meet, we actually already know how to do that. I've got my 3 lines, and I'm color coding them. If I want to find where those first 2, red and blue, where red and blue meet, I just need to solve that system of equations. We can treat them as equations to see where they hit. So let me pull that over here. So we have 2x minus y. I'm going to say equals -1. Now I know they're not equal, but we're just trying to figure out where the lines hit. So all we're interested in is the line, not the shading. So we can kind of say equal for this point. For this part, I should say. X plus y is equal to 4. Now I could use substitution or elimination on this. It's set up really nicely already for elimination, so that's what I'll do. I'll add these together. So 3x is equal to 3, which means x equals 1. And so now that I know that x equals 1, I'll plug that in. The blue equation looks pretty easy because it says x plus y equals 4. So we're going to say 1 plus y equals 4, y must equal 3. So it looks like one of our vertices, and I'll just list them, I'll list them up here at the top. One of our vertices looks like 1, 3. And I'll be checking that on my graph later, so I'm not going to plug it into the calculator at the moment. So I found where red hit blue. Now let's go where blue hits purple. So we've got x plus y equals 4. We've got x plus 4y equals 4. Again, this is kind of nicely set up for elimination. So I'll go ahead and do that. I will say to get rid of the x's, I'm going to subtract the entire second equation. So x minus x is gone. Y minus 4y is -3y. 4 minus 4 is 0. Divide by -3 on both sides, y equals 0. So y equals 0, it looks like. Let's go ahead and find x then. We know that x plus y equals 4. And on this intersection point, y was 0. So that means x plus 0 equals 4, which means x equals 4. So if I'm doing this right, 4 comma 0, x first. 4 comma 0 is my second vertex. So I found where red hits blue. I found where blue hits purple. Now let's just find where red hits purple. So I'll kind of try to separate this. That was one part. There's another part. Where does red hit purple? 2x minus y equals -1. Purple is x plus 4y is greater than or equal to 4, but I'm just going to say equals because I'm just looking where the lines hit. And for this problem, it's not perfectly set up for elimination. So I'll use substitution. That way we have an example of that as well. I get x alone, x equals -4y plus 4. And then I will plug that in here. 2 times x minus y equals -1. But I'm substituting, if you remember this, -y plus 4 in. And now that all I have are y's, let's go ahead and solve. So -8y plus 8 minus the y equals -1. So that means that negative 9y's plus 8 equal negative 1. So negative 9y's equal negative 9 if we subtract the 8 over to the right-hand side. Y equals positive 1. And now we can go and plug that back into our x. X is equal to negative 4. We know what y is now. Negative 4 times 1 plus 4. So x equals negative 4 plus 4. X equals 0, it looks like, making our final vertex of kind of this triangle that's going to be formed as 0, 1. So those are what the vertices should be according to substitution elimination, solving this system algebraically. Now let's see if we get those same vertices by putting these on a graph and seeing if that's where they hit. So here's what I'm going to do. First one, I'm going to make red and get y alone. So it's in slope-intercept form and I can really easily graph it. So 2x minus y is greater than or equal to negative 1. That means that negative y is greater than or equal to negative 2x minus 1. If I divide by a negative 1, recall, I gotta flip the sign. So y is less than or equal to 2x plus 1, flipping all those signs. So here's my plus 1, slope is 2. I can grab my ruler, draw that in. Solid line, because it was less than or equal to. And then I'm going to show you something that I didn't show above. I know it got kind of messy above. So sometimes what people like to do is only shade at the very end. And so instead of shading with my highlighter and making it kind of messy, I'm just going to draw little arrows saying, okay, I know that when the time comes, I need to shade below this line because it was y is less than or equal to. And let's see what happens. So I'll get blue. X plus y is less than or equal to 4. So if we put it in slope-intercept form, y is less than or equal to negative x plus 4. So plus 4, 1, 2, 3, 4. Negative x, down 1 over. Grab my ruler. And so less than or equal to, so solid line. And less than or equal to, again, I'm not going to pull out my highlighter just yet. I'm just going to put little arrows and say, okay, I know when the time comes, I need to shade under this line, less than or equal to. One more line to graph before that happens. Do I have room? Yeah, I do. X plus 4y is greater than or equal to 4. That means 4y is greater than or equal to negative x plus 4 if we're getting in slope-intercept form. And that y is greater than or equal to negative 1/4 x plus 1 when we divide by that 4 on both sides. So plus 1 and down 1 over 4. So I've got my ruler. This was greater than or equal to, so solid line. All of them were solid, but I need to shade above, greater than or equal to. So what do these arrows allow us to do? Maybe it's a little bit cleaner graph, neater graph, and I will shade in yellow and say, right here, this region below red, below blue, but above purple, that is the solution to my system of inequalities. And that way you just don't have highlighter and scribbles all around your paper. But the question wasn't actually graph it. The question was, what are the vertices? So we can see that this vertex is 1, 3. This vertex looks like 4, 0, and 0, 1. And so 1, 3, 4, 0, 0, 1, 1, 3, 4, 0, 0, 1. That's exactly what we had gotten above when we had solved this system of inequalities algebraically. So just demonstrating, we can solve In either way, graphing or algebraically, sometimes we'll need to do one or the other. Sometimes the problem will ask us specifically to do one or the other. But we can find vertices of where these lines intersect using substitution, elimination, or graphing. So guys, this is section 3.3 in a nutshell. A fair bit of review. If you knew how to graph inequalities from section 2.7, then this should have been a breeze. We're just graphing multiple and shading where everything got shaded from our multiple inequalities in the system. Hopefully this made a lot of sense. If you have questions, please bring them up next time we meet. But this is it for 3.3, so I will see you next time.